Hey guys, I'm here with John, and he's going to explain to us a little bit about angular momentum. Can you tell me a little bit about that?
That's right. So angular momentum is a way to quantify how fast things are spinning. It depends on how far away they are from where they're spinning and how much mass it has. And angular momentum not only has a certain speed that you're going around with, but it also has a direction. So my finger is pointing along the direction of rotation here, and angular momentum, just like regular momentum, is conserved. That means no matter which direction, I move the rest of this, it wants to rotate in exactly the same direction.
Huh.
All right.
What are these other gadgets you got?
All right, this is called a flywheel. It's the same idea. I just get this going real fast. This is going to get real loud for just 1 second here. Okay. And it's the exact same idea. As I let go, it wants to face that same direction, but it feels a force due to gravity. And so in the end, the two just kind of come to a compromise. There's a torque due to gravity. There's a constant angular momentum that wants to go around here. And that, in the end, is going to make it spin around. And if there was no friction here, this would just keep spinning and spinning forever and ever.
Forever? So
Yep.
Can I grab this?
Yeah, you can grab that. Now, if you take this and you move it without changing the direction of that rotation, you're not gonna feel anything. But if you try and change the direction that rotation is facing, yeah, you can feel it.
I know you guys can't feel this, but this is really hard to control.
And when you change the direction of rotation, that's much like a force. We call that a torque. And so that's how your simple household items, your drills and things like that work. They're applying torque to a system, making it spin or slowing it down from spinning.
All right, guys, so we're here with Grace and Emily, and I think they're going to show us a little demonstration of how momentum works, I think.
Angular momentum, conservation of angular momentum.
So what exactly is going to go on right now?
So right now when it's straight, there's no angular momentum
Oh, she's turning.
in this way, but when she turns it, then it wants to go back to zero angular momentum, so it does the opposite. So she turns it one way, then it's trying to push her the other way.
So she's turning on that turny thing just by that?
Right.
How does this feel?
Cool.
Feels cool? Well, great. How does that work? What? That's crazy.
Yeah.
So what's this you have right here?
All right, so this is much like a top. Now, there's no magnets here.
No magnets? Oh.
Yeah, it's just going to fall over unless I apply a rotation to it again. So I'm applying a torque, I'm giving it angular momentum. And as I let go, it wants to keep that same direction. Gravity is going to apply a force, and they're going to come to a compromise.
Whoa.
And it will just keep spinning and spinning. If there was no friction, it would spin forever.
And there are no magnets.
There are no magnets. This is all just angular momentum.
That's crazy. Well, thank you so much for explaining this all to me.
Yeah, thanks for
Now
visiting.
I know so much more.
All right.
That's crazy.